All right, so I talked about what the control was. So now we're going to find out. We're going to use this control to find out how to make a curve. So we already know all these. We're going to make a line to figure out the unknowns. So how we make this line? So the first thing we have to do is we know how many base pairs each one of these DNA pieces are. These are man-made DNA pieces. We made them. We know how big they are, and we just put them in a solution and put them on the gel. So if you go to your table here, your table already has that in it. So fragment 1 is 1,353 base pairs. The next one is 1,078 base pairs, and so on and so on, so forth. All right, so if we go back to this, now we need to find out the RF value. All right, the RF value is basically just a ratio of how far the DNA moved. So what you're going to do is you're going to, for each band, you're going to measure from the bottom of the gel. All right, so that's why you have to print this out on paper, and you're going to measure it down to the first band, and you're going to write that measurement in millimeters on your table under letter A here. So whatever this turns out to be, you're going to put that there. Then you're going to do the same thing, but you're going to do it for the next fragment. So you're going to go down and measure to here. All right, and then you're going to put that under letter A for number 2. All right, so you'll have some number here, and then this number will be a little bit bigger, and so on and so forth. They'll keep getting bigger. All right, so you just keep doing that for each fragment. And then you have to find point B. Now, point B is easy. Point B is just the distance that it traveled from the gel all the way down to the bottom. How far did the dye that we put in there travel? So you're trying to make a ratio of how far the DNA can move compared to how far the dye traveled. All right, so the dye traveled, you make that measurement, and you only have to measure that once, and then that is number B for this whole table. So this whole table, B, should be the exact same number because it's just a number from the well to where how far the gel moved. I mean the dye moved on the gel. All right, and then the last column, you just take A divided by B. So you just go A divided by B and so on and so forth. And you're going to get these numbers. This is the RF value that you're going to graph. All right, so that's the first part. So you're just making those measurements to determine if a fragment is 1,353 base pairs, how far would it move? That's what we're doing. If a fragment is 194 base pairs, how far did it move? So we can use that information then to figure out, okay, if these unknown samples, if we go back up here, if these unknown samples move so far, how big is this sample right here? All right, notice how it doesn't match up with one of these bands correctly, but so that's why we're going to make a curve to kind of extrapolate about how big it would be. So the curve is going to be a log graph. So this log graph, don't get confused by it, it's just like a regular graph, but instead of counting by ones or twos, we're counting by hundreds, and it's kind of spaced out weird because it's a log. And then you're going to be counting by thousands. And then here, if we continue going up, we cut by hundreds of thousands, and down here we would count by tens under the 100. So it just counts by a different set, but you guys can still use this graph. It's not too hard. What this graph is do is instead of making it a curve, it's going to make it a straight line for us. That's why we're using it. So our first one is 1,353 base pairs. I don't know how big your RF value is. I don't have that memorized. So I'm just going to make it, well, 1,353 would be about here. I'm going to make it about 2.2. So that's probably should be even a little bit lower, but that's good enough. All right, and then the next one is 1,078. So I'm going to make that 0.3, and I'm just going to go right back down around here somewhere. All right, and then it should keep going, and eventually, and you should get pretty much a straight line. All right, and that's what your standard curve should look like if you did all your measurements right. All right, so now you put that to the side, and we'll come back to that. All right, so we made that standard curve. We know if something has an RF value of 0.4, it should be about this big, about 1,000 base pairs. About 0.6, it should be about 700 base pairs, and so on and so forth. So we're going to use this to determine the unknowns in a second. So before we can determine how big the unknowns are as far as base pairs, we're going to have to do our measurements. So just as we did before, where we measured how far each one of the bands on the marker moved, Now we're going to do how far each one of the fragments for each person moved. And remember, each person has 2 fragments because they have 2 chromosomes. One allele is one STR, the other one is the other STR. So we're going to figure out how big all these STRs are. Alright, so go through. So once you measure those 2 lengths, you put it in for A for fragment 1 and fragment 2 for Diana. Then you do the next 2 lengths for Jennifer, and then the next 2 lengths for Laura, and then finally for Judy. And you'll write all those numbers there for A. And then B is the same thing as B in your last table. So you can actually go back to this table here where we did for the marker, and B will be exactly the same because it's just a measurement from the gel all the way down to the bottom. So you can put B in there, and then you just divide. A divide by B. Alright, so now what we want to figure out is how many base pairs each one of these fragments is. So what we're going to do is, like I was saying previously, so we have our standard line or curve. This one might be a little bit different, but you should use the same one that you made from your markers. And now we just extrapolate. So we know the RF values of all our unknowns. So now you just take a dotted line and you go across to the line, and then you go cross over. So if something has a RF value of 0.4, you might have 900. If RF value is 0.7, the fragment length might be 450. Alright, and just do your best to estimate as much as possible. Alright, so once you find the fragment length of each person, we will then know what alleles they have. So here's just a table for how many alleles. So if they had a base fragment that was 200 base pairs, then they would have allele 1. If they had a fragment that was 900 base pairs, then they have allele 8. So you can assign each person's allele. So what I would do is I would go back, once you find that, I would go back on here and say what number allele they have. So you can write like number 6 or number 8, and these might not even make any sense, but you write down these allele numbers that they have on there. And so then what you're going to have to do is put all that together and figure out if Judy and Diana have breast cancer, or specifically they don't have breast cancer yet. We know they don't have breast cancer yet, but are they at risk for getting breast cancer? Do they have the BRCA2 mutation? So remember, if they have the same alleles, the same markers, that means they should, as their sister and their mom, that means they should have the BRCA mutation. So what you're going to have to do first is figure out if which one of these markers do Jennifer, remember the mom and the sister and the mom, Jennifer and Laura, share, and then figure out if either Diana or Judy share any one of those markers, and if they do, they most likely have that BRCA2 mutation. Alright, and then that means they're highly likely, like 85% chance of developing breast cancer, and then we have to figure out what is their plan of action here. So that's what you're going to do. So make sure you go through and you're going to answer that. The conclusion questions, I'm going to try to give you another practice with that. And then finally, you're going to make a write-up describing to Judy what her percent chance of having breast cancer is, if she has a high or low chance based on your analysis. And then what are her possible avenues for treatment and such. All right. So that is your goals for the rest of this activity.